Let's take a look at an example from the Java libraries where they use the decorator pattern. An excellent example of the power of the decorator pattern can be found in the Java I/O library. Here I have a simple algorithm where I create a file output stream, write some content to it, and then finally close the stream. Notice that the stream is being used in two places: in the main method where I construct and close the stream, and also in the function that I called write some content to the output stream. I can execute this class, and then if I refresh the Eclipse directory, I'll see this new file called test.txt. What is interesting now is that I can introduce new behavior at runtime without affecting either the main method or the other function that creates the content. Either one of them can introduce decorators that change some of the behavior of the example. Let's illustrate that by adding a gzip output stream to decorate the file output stream. I'll have to change the name of the file to test.zip, and then I'll wrap the existing file output stream into a gzip output stream, which is really the decorator in this example. Now execute again and refresh the Eclipse workspace. You will see that we have this test.zip file. And notice we did not have to make any changes to the write some content to an output stream function to do this. We could also introduce a decorator at the function level here, or inside the write some content to output stream function. I could, for instance, introduce a buffering in this. So I could create a new buffered output stream and wrap the stream in that. If I now delete the two files, execute, and refresh again, you will see that we have this new zip file, and we've introduced buffering at a local level that is inside the function, but it still works the same way, it has the same effect, and we did not have to change main to do so. Okay, so that was the built-in libraries. Let's see if we can build a decorator pattern ourselves, and let's use the text field example that I used in my drawings. Let me first explain our starting point. I have an interface that I called graphical component that has two methods, paint and add content. I have a class that I called text field that implements the graphical component interface. It has a paint method where it prints out a set of lines that I've implemented in a simple linked list. And I have an add content that allows me to add strings to that list of lines. It's a very simplistic implementation, but it will do for the illustration of the decorator pattern here. And finally, I have a test class that I just called main. It has a constructor method that just constructs a text field and populates it with a poem from H.C. Andersen and returns it. And then finally, the main method itself just calls that construction method and calls paint. And if I execute that, we'll see that the graphical component or the text field just prints itself out using the paint method. Now, what if I wanted to introduce the border to the text field component? And let's do it right here. In early object-oriented design, someone might have suggested that you create the subclass of text field that is called text field with border, but we don't want to do that. We want to use the decorator pattern. So the first thing I'll do is I'll create a new class that implements the graphical component interface and call it decorator. It will be an abstract class. I will implement the paint method by simply forwarding to a next component. I'll have to add that as a variable to the class. This forms the chain that we talked about while I was drawing. I'll also create a constructor that allows me to initialize that next component. The design here dictates that any subclasses of decorator, so that would be the border decorator that we're creating now, will have to call the paint method of its superclass, which would be this decorator method, so that it will forward to the next component. I will eventually come back to the add content method, but for now I'll leave it alone. Next, I'll create the border decorator. This will be a class that extends the decorator class. I need to override the paint method, and I have to make a decision of how that is going to work. I could render the border before I call super's paint method that will forward to the real component, or I could do it afterwards. But just for this example, I'll make a print statement in both places. Because I created a constructor on the decorator that requires the next component, I'll have to implement the border decorator's constructor too by simply calling the super next. That should complete the implementation of the border decorator. We can go to main and inject it. The way to do that would be similar to what we did in the IO example. We need to wrap the text field into a border decorator. If I now execute, we should see we get the messages from the border decorator before and after the rendition of the text field itself, as by design. And the printout show could have rendered here, which was what we decided to do before we call superpaint from the border decorator. Then we get the paint method from the text field. And then finally at the bottom we have should probably render the border here, which was the last message we printed out after we had forwarded to the next component from the border decorator. Notice how the borders now have become an orthogonal concern or an independent concern, where we can apply a border to any of the graphical components that we might introduce in the future, whether that is a picture, whether that is a button, or anything else. The decorators are simple if the client is the one that actually introduced the decorator. It gets a little bit more tricky if it is the component hierarchy itself that has to introduce the decorators. And we'll see that in the example for the scroll bar. So let's take a look at that. With the scroll bar, we want to introduce the scroll bar if the number of lines cannot fit into whatever text box we have, which means we have to go to the text field's add content method and try to introduce it there. I'll just use some simple logic here. If the line size is 2, we want to introduce the scroll bar. And I'm just going to put a comment in for now. The problem we have now is that the client would not know that we want to add the scroll bar decorator. So how can we actually inject the scroll bar decorator in front of the text box? Or in this case, maybe even in front of the border before the text box. How can we do that? Now, using dynamic proxies and perhaps AspectJ, I could do this very elegantly, but for now I'm just going to show you an example of how it can be done. So one of the things I could do is I could have the add content return a graphical component. And I can do that by refactoring in Eclipse, so I'm just going to refactor the method to make sure that the add content returns a graphical component. Now it would be possible to implement add content in a way where we return the scroll bar decorator if we need it. If not, we just return ourselves. So I'll change the algorithm here to say when we have 2 lines, I'll return the scroll bar decorator and then pass in this as the next component. The second one, if there's not 2, I'll just return myself. Now I need to implement the scroll bar decorator. Use the Eclipse quick tip to do so. I'll create a new class called scroll bar decorator and make sure that it extends the decorator class that we just created. I'll override the paint method and simply just print out render the scroll bar before we call the next component's paint. And of course, we need to implement the constructor to ensure proper initialization. And again, we have a very simple implementation, but it illustrates the pattern, and I don't want to make it too complicated. We also need to implement the add content method on the decorator, and I'm going to simply just return this. The changes I did has an effect on the client, unfortunately. So now I need to go back into main and ensure that every time we're adding content to a component, we also reassign the variables, often called fluid design, and more common here would be to do tf.addContent and .addContent, and so on. But I'll just make it simple here and introduce this reassignment in every statement. If I now re-execute this class, I will see that I have indeed introduced the scroll bar. You see, we first could have rendered here, then render scroll bar, and then the rendition of the text field. And then we get back to the end statement that the board decorator was doing, just as we expected. To make sure that this works, we should probably also create a 2-line poem. I'll do so by simply copying the existing creation method and construct one called construct2linetb. I'll use the 2-line version from main, and then I'll execute again. And again, I get the scroll bar, and this is because I made the algorithm such that if it was 2 or more lines, we would have the scroll bar. But I'll change the algorithm so that it requires at least 3 lines. So I'll go back to the text field and change the boundary on where we introduce the scroll bar to 3. And if I now go back to main and execute, we see that if we have only 2 lines now, we don't get the scroll bar. With more than 2 lines, we get the scroll bar. It was dynamically introduced now within the component hierarchy. A contrived example perhaps, but it shows that that is also possible. And again, I would rather have used something like dynamic proxy or aspect J to implement that part of the decorator.